Hi everyone, I am Diane from Singapore Tutors. So we'll be going through primes and prime factorization today, and for this whole series we'll be focusing on the syllabus for GCE mathematics for 2016, elementary mathematics for 2016. So let's go. So before we start, we need to understand what it means by prime or prime numbers. Right. So prime numbers can be divided. A prime number can be divided by evenly only by 1 or itself. Okay, and it must be a whole number. So meaning that it cannot be a decimal number. It cannot be rational or irrational number, and it has to be greater than 1. Okay, so meaning that 1 is not a prime number. Okay, remember 1 is not a prime number. So we start with 2. So if you think about it, 2 can be divided by 2, okay, which is itself, and 1. Okay, so 2 is a prime number. Then 3 is the same as well, because 3 can divide by 3. 3 cannot be divided by 4 without giving you a remainder, right? And then what about 4? Is 4 a prime number? So if you think about it, 4 can be divided by 1. It can be divided by 4, but it also can be divided by 2. So from the definition, it says that a prime number can be divided by evenly only by 1 or itself. So now apparently there's another number. So obviously 4 is not a prime number. Okay, so we move on to 5. So 5, yes, it is a prime number because it can be divided by itself, 5, and it can be divided by 1 and not other numbers. 6, nope, because 6 can be divided by 1, it can be divided by 2, which gives you 3. It can be divided by 3 as well. It can be divided by 6 itself. So 6 is nope. Then it's 7. Then the next one is 11, because 8, 9, 10, they are not prime numbers if you think about it. And then the next one is 13, and then the list goes on. Okay, so this is the first thing you know now. What is a prime number? So the second thing you need to know is what are factors. So factors are the numbers you multiply together to get another number. So for example, I just come up with the 3 times 2, right? These two numbers multiply to give us 6. Okay, so these are factors. So these are the factors that gives us 6. So what does this got to do with prime factorization then? Okay, so we know that prime numbers, there are 2, 3, 5, 7, 11, 13, 17, and then it goes on, right? So what does this have to do with all these prime numbers? So basically, prime factorization means that we want to break a number down to its prime number, okay, to the most simplest form. Okay, 2, 3, 5, 7, 11, 13, 17. You can think about it as the most simplest form, because we cannot break 2 down even more. We can't break 5 even more. Like, we can't break it down even more, right? If you think about it. So this is the main objective of prime factorization. So let's do a simple example. So what are the prime factors of 12? So what we're going to do now is called prime factorization. Okay, Okay, so meaning that we want to break 12, which is not a prime number, into so we want to break 12 into its prime numbers. Okay, so we have to keep in mind of this. Okay, right, so how do we do it? 12 can be divided by 2, so 2 is a prime. It can, so which gives us 6, and then it can be divided by 2 again, which is a prime, and it gives us 3, and then 3 can be divided by 3 again. Okay, so what we have here is 2 times 2 times 3. 2 times 2 times 3 is equals to 12, correct? And then 2 times 2, okay, this is one mistake that some students would make, is they will write it as 4 times 3 and not realizing the objective of the question is that they want prime factors. 4 is not prime, so we do not do it like that. Okay, we instead rewrite this 2 times 2 into 2 square times 3. Okay, so this is the answer. Okay, and if you think about it, if 2 times 2 is equals to 2 square, or 2 to the power of 2, 2 times 2 times 2 times 2 will be equals to 2 to the power of 3, or 2 cubed. Okay, so this applies to 2 times 2 times 2, so this applies to 2 times 2 times 2 times 2, which is equals to 2 to the power of 4. Okay, they all applies, the same rule applies. So this one you'll learn more in the next chapter called in sets and indices. Okay, but not now, but it's good to know for now. Okay, so this is our final answer. Okay, so moving on, this next question, you see we have a much bigger number than before. Okay, it's 840 instead of 12. So if you think about it, 840 is obviously not a prime number, so therefore what they are asking you to do is to break down into prime factors. Okay, so they want you to express 840 as a product of its prime factors. It's the same meaning as the previous question, saying what are the prime factors of 12. It's the same meaning. Okay, so basically what you want to do here is to do prime factorization. Okay, so this is what you want to do here, but you want to do it on the number 840. So 840 is an extremely big number, but no worries, because if you think about it, 840 can be divided by, if I put 10, 84. So you can use the similar method like I did just now, like here, okay, to slowly break it down. Or you can do this method, which is, to me, is much faster, okay, because this question is only 1 mark, there's no point, or like, because this is a huge number. So to me, immediately when I see it, 840, I know that it is 84 multiplied by 10, right? So immediately when I see it, it's 84 multiplied by 10, which I will further break it down, because 10 is 5 times 2, so these are primes, but 84 is slightly different. So 84 is, okay, maybe I just divide it by 2. So 84 divided by 2 is 42, right? Then now 2 is a prime, okay? So now what we have left is 42 to break down. So 42 is actually, if you think about it, 6 times 7. Right, then the rest remains times 2, and then times 5 times 2. Right, so we want to break down this 6 and 7, which gives us, so 7 is a prime, but 6 is not a prime. So 6 we can break it down to 3 times 2, right? And then the rest remains, right? And then times 5 times 2. So now we want to do a little bit of a rearrangement. As you can see that we have 2, 2, and 2. We have 3 2's here. So what is going to happen is that we will merge it up like what we did just now. Okay, just now we have 2 2's. Now we have 3 2's, so it's 2 to the power of 3, right? Then times, so since we only have 1 3, so we just copy it. 1 5 here, we just copy it, and then times 7. So this here is the final answer for this question. So it should be done pretty quick, like a 1-minute thing or 2 minutes maximum during O levels, and then you should move on to the next part of the question. And you must get this correct. Make sure that you don't do any careless mistakes, because later we go through some more challenging question and you'll realize that all these prime factorization questions are like the part A of the questions. So if you don't get this correct, your part B and C and D will be wrong. Okay, so in order to ensure that you're correct, I know it's kind of a little bit time consuming, but you have a calculator, just type this in, okay, and double check if you actually get 840. All right, okay, so in the next video we'll go through highest common factor and lowest common multiple.